Welcome to part 25 of our series on building a Zelda-like game in Phaser 3. In this video, we're starting a brand new section focused on integrating our tile level into our game. We'll begin by setting up our tiled scripts and creating our background and foreground images for our level. If you're new here, this is part of a full series where we create a Zelda-inspired game from scratch. Check out the playlist link in the description to start from the beginning. Alright, let's dive in and start building our world. Now that we've built our level data and tiled and structured everything the way we need, it's time to bring our dungeon to life inside our game. In this section, we'll take the level data we created and use it to generate our dungeon dynamically in Phaser. We'll load our tile maps, set up our collision layers, and place objects like doors, chests, and enemies exactly where we define them in tiled. By the end of this section, we'll have a fully functional dungeon layout ready for exploration. So let's jump in and start loading our first level. Before we start building out our levels in the code, we need to set up some important scripts that will help us work with our tiled map data. These scripts include utility functions and TypeScript types that will make it easier to handle things like object properties, collisions, and level transitions. We actually already downloaded these files along with our tiled map assets, so now we just need to add them to our project. Let's get those set up so we can start bringing our levels to life. So previously when we downloaded our tiled assets, inside the folder there was a scripts folder. This scripts folder has scripts that we'll be using in our game, so we need to copy this tiled folder here. And we'll want to place that in our project source code, so under source, under common, we'll want to place that tiled folder here. And we should have three files, common.ts, tiled utils, and then types.ts. So before we start working our code, let's quickly review these three files. So under common tiled, our common.ts file. So this file is going to have a bunch of different objects that define the various keys of elements we worked with in tiled. This will include things like our property names on our objects we created, our layer names, our tile set names, and even our enum values that we defined on our objects. And so by defining these all as objects in our file, it'll make it easier to reference these from one location in our code base. Then under our types file, this has all of our TypeScript definitions for our various objects that we created in tiled. So we'll have this base tiled object here that has some core properties like our X and Y, our width and our height on our object. And then we have this tiled object property that defines the various properties that we use on our objects. So then we'll see below that we have a variety of object types. So like our chest, our door, our switch objects. So all of those objects we created in tiled, now we have this TypeScript definition that represent those objects. Finally, under our tiled utils file, this has a bunch of utility functions that are going to be useful for parsing our data from tiled and from grabbing our objects from our layers and then constructing our various objects based on those types that we just reviewed. So as an example, we have this get tiled objects from layer where we can provide a tile layer name, and it's going to grab all the various objects and build those objects based on if they have the properties that we expect. And so all these utility functions, we'll be using these in our game, and we'll go into more detail on these as we get to them in our code. Now that we've finished reviewing our new scripts from tiled, we can move on to creating our background and foreground images for a level. In order to create the correct image game objects in our game scene, when our scene starts, we'll need to know which level or area our player is currently in. Currently our project is set up under our public assets folder, under images, under levels, we have our two main levels. We have our dungeon and then our main overworld. And for each of our levels, we're going to have three assets we'll need to utilize in our game scene. And so we're going to have our background and foreground images. And then our JSON file has all of our metadata from tiled that we'll need to parse to create our various game objects. And so in our game scene, we'll need to know which level our player is currently in so we can reference the appropriate assets when we create our image game objects. And so in order to do this dynamically, one of the options available to us is when we start our scene in Phaser, we can pass additional metadata to that scene. What this means is in our preload scene, we can tell our game scene which level our player is currently in, and then we can update our game scene to use that information so then we create the appropriate game objects. And so to do this, let's open up our preload scene. And now when we call our start method, one of the things we can pass is we can pass this additional data object. Now this object can be anything we want it to be. And what we'll do is we're going to pass in our level name of where our player is currently at. And then our game scene will use that to load the appropriate asset. So as an example, if I just do level and I'm just going to do test. And so how this works, when our scene now starts, when Phaser calls our init method, it's going to pass that data to us. So if we jump back to our game scene, let's add an init. For our argument, we're just going to add in data. We'll return nothing for our type. And I'm just going to do console.log, and we'll do data. Alright, so now if we refresh our browser, we're going to see right away, as soon as our scene is initialized, we now have that object with our level property available to us. And so by using this method, now anytime we start one of our scenes, we can pass additional data to that scene. So now that we have a way to pass our level information to our game scene, let's define a type for this, and then that way we can reference that in both of our classes. So under our source folder, let's go under common, let's go into our types file, let's make a new type. We'll do export type, we'll call this level data. Now for our type, we'll want to add 3 properties. The first is going to be our level, so which level we actually want to load. Then we'll want to know what room ID our player is currently in. Then we'll want to know which room ID to add our player to. So as an example, when we transition from our world scene into our dungeon, we'll need to know that our player is in this room here, and so from tiled, this would be our room 3. And then finally, we'll also want to keep track of which door that our player is entering in through. So then that way we can place our player in the appropriate location. So if we jump back to our type.ts file, we'll add in our level. For now, we'll just do this as a string. Now we'll do our door ID, this will be a number, and we'll do our room ID. So now for our level names, we'll want to define these as an object and create a type for that. Let's open up our source common and we'll go into our common file. Let's make a new object, we'll do export const. We'll call this level name, and so for our object, we'll do as const. And now for our 2 levels, we'll do dungeon 1 and world. So we'll do world. Now we'll do dungeon 1. Now to create our types, let's go back to our types.ts file. We'll do export type. We'll do level name is equal to our key of, type of, and we'll do our levels names. So now down for our level data, let's update our type to be our level name. So now let's jump back over to our preload scene. So now we'll make a new object to pass our data. So let's do const, we'll do scene data. Let's add in our type, so we'll do level data. So this equal to an object. Now we'll do our level. Let's do our level name. Let's do dungeon 1. For our room ID, we'll just set it to 1, and door ID, we'll also set this to 1. So now we'll update our call here to use our new object. And then finally, I'm just going to add a to-do here, and so we can come back and update this later. So currently our code will be hard-coded, and we'll actually want to grab this from our data manager later once we add that in. So now when our scene refreshes, we should see our objects being logged to our console, and we'll see our door ID, our level, and our room ID. Now what we can do back in our game scene is we'll want to store a reference to this data so we can use it down in our create method. So let's add a new property to our class. We'll call this level data. For our type, let's do our level data. Now down in our init method, we can add in that type. Let's add in level data, and we'll do this. Our level data will be equal to the data we received as our argument. Now that we have our level information, now we can create our foreground and our background images. So now down in our create method, after we create our controls, before we create any of our other game objects, we'll want to create our background. And then that way, any game objects we create will be placed on top of it. To create our background, we just need to add an image game object. So we're going to do this.add, we'll do our image. Now we'll do 0, 0 for our location. And now for our texture, let's reference our asset keys. This is now for our property, we're going to want to do our dungeon 1 background. But to create the correct property, we need to reference our level data. So we'll do this, our level data. Let's grab our level name, add in our underscore, and now we want to do our background. After we create our background, we want to set our frame to 0. And then finally, let's update our origin, and we're going to put this in the top left-hand corner. So we'll set our origin to be 0. So now when we save, when our browser refreshes, we'll see our background images has been added to our game. All right, so we want to test our world level, jump over to our preload scene. All we should need to do now is if we update our level name to be world, we'll see now when our scene refreshes, we now grab the appropriate image and we add that to our game. Nice. All right, so now back in our code, let's update our preload scene. We're going to revert this back to our dungeon and let's jump back to our game scene. Now we want to create our foreground. So now for our foreground, we just need to add another image game object to our scene. So let's copy this, we'll paste it. Let's update our asset key name to be foreground. And one last change we'll do is for our foreground, we need this to appear on top of all of our other game objects. And so we'll want to update our depth. So after we call set origin, let's do set depth. And we want to change this to B2. All right, so when we save, when our browser refreshes, there should be no visible change to our game. And so if we want to test our foreground, we just need to update our object's positions. And so let's update our background and our foreground to be at -20 for our Y value. All right, so now if we refresh our changes, if we move our player down through our scene, we'll see now our player appears behind our foreground. And so when our player goes through our door, it looks like they're going under that tunnel. Nice. So back in our code, let's revert our change and we're going to go back to position 0. Now that we have our background image in our level, we need to add in the ability to have our player to be able to actually traverse our level. Currently, we're limited by our phaser camera and what's actually visible to our player. And so how phaser works, each scene that gets created has one main camera that gets created with it. That camera is going to control what's actually visible on our canvas element, and by default, that camera uses our settings from our game configuration. So in our game configuration, we set up our width and height to be 256 by 224 pixels, and so that is the view of our world that we're actually able to see. And so in Phaser, your world dimensions are actually infinite, and so once you get past your 0, origin point, you'll keep moving in the positive direction or the negative direction. And for you to show more parts of your world, we need to update our camera's positioning. One of the easy ways to do this is we can have our camera follow our player, and then that way as our player game object moves around our world, our camera is going to follow it. To make this change, if we go into our create method after we add in our images, let's do this. We're going to reference our camera, so reference our cameras manager for our scene. We're going to reference our main camera, and then if we call our star follow method, this allows us to provide a target game object that our camera should focus on, and it's going to follow us around our world. And so for our game object, we want to reference our player. Since we create our player after this, let's move this line at the bottom of our create method, and that way our player will already be created. So now when we save, when our browser refreshes, we'll see now our game object is in the center of our screen, and it is the primary focal point for our camera. Now as our player moves around our world, we'll see our camera keeps updating to follow our player. Now that we've updated our camera to follow our player, before we move on to loading our tile JSON data, we're going to work on refactoring our create method a little bit. Currently, we're doing a bunch of logic for creating our various game objects and adding them to our scene, and our create method is getting very large. Instead, we want to move some of this logic to its own methods, and then we can follow this pattern here, where we have these methods be responsible for one thing. To start with, we're going to create a method for creating our level data. We'll have one for setting up our camera. We'll have one for creating our player. Then for all of our other game objects, we're going to place that in a temporary method, since we'll be recreating these objects later once we start parsing our tile JSON data. So to start making these changes, let's come to the bottom of our class, and now we'll define our new methods. So let's add a private method. We're going to call this create level. For this method, we won't return anything. I'm going to copy that block of code. We're going to paste it 2 more times. And now we'll have one called setup camera, and then we'll do setup player. So now if we come back up to our create method, let's copy our code for where we update our camera. We're going to place that down in our setup camera method. Next, let's grab our logic for where we create our player. Let's place that inside our setup player method. And now if we go to where we create our images for our background and foreground, we'll place that in create level. And then finally, let's add in one more method. We're just going to call this temp code. We're going to place all of our other logic where we create our game objects into that method. So let's copy our logic for our blocking group, our pot game objects, and then our enemy groups, and then our game scene text. And we're going to place that down in that other method. So now back in our update method, let's update our code to call our new methods. So after we create our controls, we'll do this. Let's do create level. Now we want to set up our player. And now we'll want to set up our camera. Now for the time being, we'll call our temp code method, and then we'll call our register colliders and register custom events. So now if we save, our scene should refresh, and we should still see our game objects, and our player should be able to move around our level. Nice. Finally, one last change we'll do is we're going to re-enable our spider and our Wisp game objects. So if we open up those classes, let's go into our Wisp, we'll update our state machine, so we go into our bounce move state, let's open up spider, and we'll do the same thing where we go into our idle state. That's it for this part of the series. If you found this helpful, be sure to hit the like button. It really helps out the channel. And if you're following along, make sure to subscribe and turn on notifications so you don't miss the next video. If you have any questions or want to share your progress, drop a comment below. I'd love to hear from you. Alright, thanks for watching, and I'll see you in the next one.